Hello, everyone. My name is Mauricio, and I'm here to talk about scaling test strategies. But before, let me introduce myself. I work for Agin. At Agin, I'm a tech lead, and I lead a team called Testing Enablement. And the goal of the team is to enable other teams at Agin to do better testing, but also to build tools so that they can write those tests in a much easier, more effective way. I used to be an assistant professor at Delft. A lot of my research was focused on software evolution, maintenance, and testing. I'm the author of the Effective Software Testing book published by Manning in 2022. The focus of that book, as I'm going to say in the talk, was more from the developer perspective. In this talk, I'm going to zoom out a little bit more and then talk about the perspective of a company that is trying to scale in testing in general. I'm originally from Brazil, but I live in the Netherlands for a couple of years now. Those are a few pictures of the small city, or not so small for the Dutch standards, the city that I live. Before I get to the topic of the talk, let me start with a personal story. So this was back in end of 2005, and I was working as a consultant for Verifone. Verifone is this American giant, and they produce POS's, point of sales. So basically, the machines you put your credit card, you type your password, and then a payment happens. I was working for a small consultancy in Brazil that would do services for them, and then there was this new project that was all about automating gas stations. Automating gas stations is not new novel today. All gas stations are automated, but back in those days, this was still new, and Verifone wanted to feel the waters on this market a little bit. And because I had some knowledge already on the platform, um, the small consultancy put me as the team lead of a very small team for people that would build this product. And this was the first moment in my career that I was leading people. Um, and in my mind, it was like this is going to be the best software product ever. So we spent a few months, maybe almost a year, coding something up to the moment where we could ship our MVP, so to say. Back then, of course, those ideas of shipping really fast and learning didn't really exist. Also, as you can imagine, this involved a lot of hardware and physical installation. So we would need to modify the gas pumps so that they could talk to our system, so on and so forth. But we worked very hard to have a lean version and deploy it. And then the time arrived. As you can see in the picture, this picture was like a day before we went to the first gas station and made the installation. Month number 9, that's September, if I'm not mistaken. I'm very bad at months, 2006. And this picture was taken in Dominican Republic because the first customer they found was there. So, we were ready for it. Um, and then we made installations, everything was working fine. I monitored the application the whole day, and then we all went to the beach, the beautiful beach under the Caribbean Sea, to celebrate this accomplishment. And I recall the owner of that gas station saying that this would save him a lot of time and money. So, a lot of, a bright future ahead for the application. But of course, life isn't that easy. When it was 4 or 5 a.m., the phone at my hotel rang, and it was the owner saying that the application had a bug. And because of this bug, no one could refuel their cars. So people would get the nozzle of the gas pump, they would press the nozzle, but no gasoline, no benzene would go out. And that was sort of the behavior of the application. If you're in a, if you don't know where you are in terms of state, just don't allow people to refuel their cars. I just remember, rushing up to the site, looking at some logs, identifying the bug, patch the application, redeploy, and then everything was fine, back to normal. And I spent a week there. No other serious bugs have happened, but I could see that the owner of the gas station didn't trust on us. so much anymore. So that was sort of the lesson for me that testing is really, really important, and maybe one bug can totally destroy the product. This product never really made into sales, unfortunately. I don't think it was because of this particular situation, of course, but it was sort of a life call for me. Cool. So let's talk about testing and scaling testing more specifically. First topic, scaling. I have 4 topics as you saw on the previous slide. I'm going to go through each of them. So when it comes to scaling testing, so think of how do you convince a company with hundreds of developers to write a lot of tests. Um, that's the point of this part of the presentation, okay? And the first thing I want to mention is, and this fight we used to have before, unit tests versus integration tests. What is a unit? Is this one class in isolation? Or, if I test 2 classes together, is this still a unit, or is this an integration test? Back in the 2000s, we were so focused on really understand the test levels and making sure that if it's a unit test, it's really isolated, so on and so forth. And that made a lot of sense back then when we were writing tests on the scale of hundreds, but now we are on the scale of thousands. And this discussion is important, as I'm going to mention later in the presentation, but I think I want to draw attention to what I think it's more important right now. That is that regardless of if we're testing 1 class or 2 classes together, if we're mocking, if we're not mocking, if we're going to the DB, if we're not going to the DB, if you're allowing file reading and file writing and so on and so forth, it doesn't matter. What truly matters is that tests should run very fast. Why is that? Because a test that runs fast, you can run them multiple times in your local development, and that's great for the developer experience. But it also means that once you are on the scale of thousands of tests, you can have your CI running those tests all day long. Someone opens up a pull request, you can run all your tests because they run very fast. If a developer adds 10 new tests to the code base, that makes no difference to your CI infrastructure. You can still run those tests. If your tests are very slow, let's say each test takes a minute to run. If you have 100 of those tests, you have 100 minutes to spend. Maybe they're also computationally expensive, so you would need more CI, your builds would be slow, so on and so forth. So regardless of what you decide as a team, how to write tests, what you should truly focus is, okay, this is our decision. We believe for this system that we're building, the best is, let's say as an example, not to mock the database and use, test containers and spin up a Postgres image so we can write the tests. The focus should be, okay, this is how we want to write tests. How can we make it very, very fast? If it's slow, the problems will happen. And you see that this discussion is not really new. In the Software Engineering at Google book, published in 2018, if I'm not mistaken, you also see a similar discussion there in the chapter about tests. That what truly matters is that a test is fast, right? If you think of as a platform team, this is also interesting because this means you stop really being concerned about what the developer is doing in that particular test. You don't want to give one rule for your 100 developers. What you care is, or what you can say to teams is, your test should run within X milliseconds. And if you do this, I promise you I'm going to run the tests on every pull request. Yeah? So that's lesson number 1. Focus should be on fast tests. And cool. That being said, what you also see in practice is that although you can write lots of very fast tests, at the end of the day, you still want to write integration tests regardless of your test philosophy. You still want to write some integration tests or some other types of tests, whatever, that can be quite slow. So what you do, you cannot really run them in every pull request. You run them post-merge, right? After the code is merged. So like a job that every 1 hour or 2 hours clones the head of the master repository, compiles and runs those tests. And this is really great, right? This is really great because you want to give teams an opportunity to write more expensive tests and also get timely feedback. A test that runs every 2 hours is not as good as a test that runs at every pull request, but it's good. It's good enough. Uh, that being said, what I want you to have in mind is, as soon as you give teams the possibility of doing both, you can write very fast tests and I promise to run in the pull request. But for more expensive tests, you can only run them in post merge. You also have to sort of explain to the team that pre merge is where you want to have most of your coverage. Um, why is that? Because you want someone to open a pull request and you want to block this pull request from getting merged if it breaks behavior. If you only know if a commit breaks the behavior after the code gets merged, maybe you get 100, 200 commits merged, then your test suite runs, and then you have lots of broken tests. And this means you have, like right now, a master that is super unstable, full of bugs, that's going to force developers to stop what they're doing because they already moved on to the next task, to stop what they are doing and to stabilize and master again. So those post-merge tests, they should serve as a sort of second layer of protection, the ones that are, investigating more, cases that, maybe you need multi-threading to simulate, or, as a second layer, like you have your most important flows, they are tested in the pre-merge, but you also want to write more expensive tests that exercise the same flow just so that you're double sure things are working. Maybe now in a more realistic setting, so on and so forth. They should serve as a sort of second layer of protection. Your first layer of protection should be based on fast tests, and they run pre-merge. So the more you can avoid a broken code to get merged into master, the better, of course. And if you work on a small scale company, it feels like insane that someone would prefer to get their tests ran only post merge. But trust me, in very large scale where people are writing complex software systems, maybe with a lot of legacy, sometimes that's sort of the easiest thing that they can do. Integration tests tend to be the easiest thing to do when you're in a legacy system. So it's tempting to go that way, but help them as maybe an enabler that you are, so that they find a way to start having more coverage in their pre-merge. Define your own test pyramid, or letting teams define their own test pyramids, is also very important, right? And what do I mean by this? That we have famous test pyramids online. Some of them say you have to focus a lot on unit tests and then you write less integration tests. Others say you should focus more on integration tests and write less unit tests. I think there are different solutions for different contexts. You've got to really understand the type of software you're building. But once you do, please formalize this in I say pyramid here, but it can be in whatever you prefer, right? Something that explains to people how do you get stuff tested, like something like, we write a lot of, background jobs. That's how you write a test for a job. We write a lot of API endpoints. That's how you test an API endpoint. That's how we like to do it. We do database access a lot, so that's how you exercise your SQL queries. So you sort of understand the software people your team is building, and you have guidelines on how to help people write the best test they can. Again, in small scale, that doesn't make a lot of sense, but in large scale, you don't want people reinventing the wheel. Uh, whenever you hire someone or someone moves to a different team, you don't want them reinventing the wheel. So giving them something to get started from is very important. Believe me or not, I've spoken to a lot of teams, and they were precisely stuck on such types of discussions. How should I test this and that? And they were not really getting testing done because, of course, they have to keep pushing features to production while they are still discussing how to test. Just because that there were disagreements, they never really sat down all together to explore together how tests should look like in their application. As someone that is working on a platform like me, on a testing platform like me, offering testing services to people, you have to help the engineers on the field designing test suites with parallelism in mind. Because as soon as you're very large, you are going to have to run tests in parallel. Um, and of course, you don't want to make promises that these tests will always run together with this other test and this type of thing. So you want us to be fully independent. And why is that? Because that simplifies a lot your infrastructure. If you can just run tests in parallel and you can increase the number of tests in parallel you run or decrease it, so on and so forth, without um, having broken, flaky tests, that's the dream, right? And this problem becomes really clear to see once you're trying to scale test suites of legacy systems, right? So imagine a legacy system has lots of tests already, but maybe written, in the way people would write tests 15 years ago, and then now you have to, you're working to improve their build times, test execution time, and then you start to parallelize their tests, and then suddenly you see that as soon as you parallelize, all the tests are breaking. So if you can help your teams to understand how to build tests that are truly independent from each other, that's a great benefit. If you're at that moment where you see, we're getting to the scale of thousands of tests and, dozens of things, building things differently at the same time, focus on this. On the bottom left, there's a paper there called an empirical analysis of flaky tests. It's a bit of an oldish paper now. I think it's from 2016 or so. But I like this paper very much. I think it's still very relevant. The authors looked at a lot of flaky tests in the wild, and they tried to categorize what caused the test to be flaky. And number one or two or three, amongst the top three or so, parallelism was there. So this means a lot of the flakiness happened because tests are not really made to run in parallel, right? As an example, what can cause a test to fail when you run them in parallel? Maybe all the tests share the same database, and then there are conflicts for the database, or a lot of in Java, maybe a lot of static context initialization, and this type of stuff. It's very common that you run multiple tests, maybe running them on the same JVM, so there's some shared state there. So everything can go wrong when you parallelize. So pay attention to this. At Agent, what we do is we thoroughly monitor the tests that present some flaky behavior, and we notify the developer, hey, we've seen a pipeline where this test presented the flaky behavior. We don't know why. Our system is not that smart to give you a guess on why. But hey, now you know that this test is being flaky sometimes. Take a look at it and then try to improve. So I'll talk about it, but usually those two lines of work are very important when you're thinking of scaling testing in general. One is, of course, you want to give people tools so that they can avoid the mistake altogether. And as a platform, you also want to monitor. So if a test breaks the rule, you can see it and you can notify the rightful owners. Also, if you're really planning on scaling testing, in the sense of having thousands and thousands of tests written, you have to make it easy for people to write tests. If you're in a situation where people are not really writing a lot of tests, for sure that can be due to lack of preparation of the engineer, laziness, so on and so forth. But all my money would be on the fact that it might be really hard to write a test for your application. Writing a unit test is very simple on toy projects where you just instantiate one class, you pass some values, you call a methods. But in real life enterprise systems, writing a test that matters, that truly exercises a meaningful feature would require, data in a lot of tables and a lot of entities being created. Setting up the state of the system can be quite tricky. So you got to make it easy for people to write such tests. Otherwise, what's going to happen is even a developer that is trying their best, the person would write the first test. It would take, I don't know, a day to write a test. I'm pretty sure a lot of you have been on this situation where it took you a day to write a test, and then the second test takes much less because you can copy a lot from the first test, and then you write test number 3, and then you're sort of done because you don't feel productive anymore, and then you just want to move to the next feature. Whereas if writing tests is easy, then it feels very natural for you. Let me see what happens in this specific corner case if I pass a 0 or a negative number or a null to this field. How do you make it easy for people to write tests? Talk to your engineers, understand their pains, and then build layers, frameworks, libraries, whatever, that help you write tests. So we're very used to write libraries and frameworks to help us be more effective when writing production code. We should do the same for testing, right? Same principle, simplify your life, make something that is hard, put an abstraction on top of it so people can more effectively do whatever they want to do. Also, in very large scale, which is, for example, our case, Agen. We are a payment company, by the way, for those that don't know us. We process payments for large companies like Uber, Spotify, Netflix, and we offer lots of financial services. So our application is truly, truly complex because the financial world is truly, truly complex. When you're at that scale with hundreds of services running, it is natural that you feel like you want to write a test that would cover as much as possible. And maybe that means writing a test that would require 30 systems to be up and running, 10 jobs to be running on the background, 3 different databases, distributed, so on and so forth, which is super cool. Maybe you find a way to simplify such a test, but usually it is quite painful to write a test that requires so many of those systems. So a very hard trade-off you have to do in practice is to reduce the scope of your tests to up to a point where it's still meaningful. So if the test fails, it gives you, or if the test passes, this gives you good signal about the state of your application. Not big enough for you to suffer, not small enough so that you start writing useless tests, right? So finding the right granularity of your tests can be quite helpful. So very, simplified example. Imagine system A sends a message to system B, also sends a message to system C, and system C sends a message to system D on my middle right. If you really want to write a test that covers it all, infrastructure-wise, you need to find a way to have all the systems up and running, right? Sure, that you can solve probably with some amazing DevOps engineer, you make it happen, great. But then as a developer of system A, and probably system A is developed by one team, system B is developed by another team, so on and so forth, because those are big, chunks of functionalities. As a developer from system A, you know nothing about system B. But if you want to really write a complex test, system B, you need to understand system B because you want system B to respond in a specific way, given a request you're going to make to it. So it is more complex from an infrastructure point of view, and from a testing point of view, you sort of start to have to open boxes you don't know so much about them, and that's very hard. And second, your team is moving really fast, but you can also bet that the team that builds system B is also running very fast. So it's likely that at some point system B will break, and their build will be crashing, and they will have to fix their builds. But as a team developing system A, you don't want every time the team B makes a mistake that this affects your productivity, which is sort of what happens if your integration tests truly depend on the real system B. So maybe a suggestion would be a lot of your tests, make them isolated, make them as big as possible within your system A, the system you have control, right? So you don't have to write unit tests. You can test large pieces of functionalities in your own system, but you can still mock system B. You can still mock system C. So in this sense, you still have control over your own test suite. B and C will never break you. And that gives you, good pre-merge tests. They run very fast. You can get good feedback, and people from other teams will not prevent you from working. Of course, in such a situation, I have to mention that if you're really doing this, at some point you will need either contract tests or integration tests to make sure that if system B evolves, your system can still talk to system B, and you both are speaking the same language, right? So um, there's no silver bullet, so to say, right? Um, and I think my point here is you are going to have to make trade-offs to simplify the lives of your developers, your infrastructure, your productivity. And let me continue on this topic. Usually, the biggest fight back I get from people when I say, maybe you don't need to test your flow with 30 other production systems altogether. The answer is, but I have to do it because the bugs that happen in production, they only happen when all those systems are running together. Unit tests don't catch those bugs, right? Which is sort of true. A lot of the hard bugs, they happen when weird combinations of messages happen. For sure, that is certainly true. But what I want to mention here is two things. So the first one is the types of bugs that happen in production in such a weird corner case, one in a million times, situation in production. Even if you're writing integration tests, you will never catch those bugs because you're not that smart. You're a human, and you cannot really see so deep. You know, people have been relying on AI. Even before LLMs and the new fashion cool AI, people have been relying a lot on search-based algorithms and intelligent techniques to explore weird combinations. In integration tests, the most you're going to be able to catch as a human writing a test would be configuration errors. When you put everything together, does it go up or not? Contract problems, maybe you send a message to system B returns, stops working because someone made an API breaking change there. These type of stuff, sure, you can catch them via integration tests, but you're never going to catch that bug that happens if a message gets 10 milliseconds later than it should get to your system. So have that in mind when writing such an expensive test, that you'll be able to mostly, try to understand the category of bugs you as a person can catch via integration tests. Yeah. And second, don't underestimate the ability of simpler tests to catch bugs. The paper on my left, Simple Testing Can Prevent Most Critical Failures, it is a primer paper to read to convince people that don't believe in simple testing. And what the authors there did, they looked at very complex distributed systems. So think of Cassandra, Hadoop, Redis, and they looked at the bugs and they looked at the patches and they tried to understand sort of, could this bug be caught by, a very small simple test? And to their surprise, the answer was yes. A lot of bugs can be caught via simple testing, right? Because that's life. A lot of our bugs are, null pointer exceptions or, combinations of values we forgot to test that you could test, only with a few small subset of components in your system. You don't need the whole system to test something, right? At Agile, we have this sentence in our internal wiki that says, don't write an integration test that could have been a unit or a component test. Because simple tests can catch a lot of bugs as well. Now, testing the legacy. If you're working on a successful company, it is likely you have legacy to handle. How do you do this? First of all, I see people giving this suggestion. I've seen these in books from famous authors, and of course, books written 20 years ago, maybe that suggestion made more sense then, but now not so much. And the suggestion is yeah, if it's impossible to test, just refactor the code and then write a test for it. And I find this a very bad suggestion. Why is that? Because first of all, refactoring some legacy system to make sure it's more testable, it is a lot of work. It's hard, it's expensive, it's prone to bugs, right? Because of course, in practice, what prevents you from testing is not that you have, a 200 lines method that you can quickly break it down into smaller components, whatever, move to different classes and then get them tested separately. No, usually the technical debt is way more complicated. So these refactorings are never simple. Um, Second, the legacy is full of code that you don't understand and you're refactoring it. How are you going to be sure that your refactored worked in first place if you don't have tests? How are you going to refactor such a probably core component of your application without tests? Also, in a lot of cases, if you're focusing on testing, refactoring is not your number one goal, right? Your goal is to write tests, not to refactor. In a lot of cases, the legacy system might suck, might have old decisions, but you can still maintain it. It still pays our bills. Why would you refactor something that is working um, just because of testing? I don't think that's a proper reason, right? So this idea that refactoring will come first, I don't believe in that. What do I believe? I believe that if you're in a legacy system and you want to write tests, you will have to write libraries or frameworks or scaffolding or something that will help people to test the legacy. Dive deep into the problem. What makes the legacy harder to be tested? Is it because it's hard to set data up on the database? Is it because the system has lots of hard-coded IPs that are very hard to be replaced in real time, so that you can simplify your testing and whatever, make an HTTP call locally? I don't know. Understand where the pain is, and then write a tool or do a very chirurgical refactoring on the code base just to tackle that problem. You're going to be way more successful, if you ask me, if you approach the problem like this. In practice, to be really honest, I feel like if you just go to the developer and say, the developer says to you, hey, help me test this, and then you say, just refactor your code, the developer will never do this because he or she is not crazy, right? They will not really refactor something that they know is very complex, that they understand very little. They know it's going to break. So a developer that understands about the legacy would never do this in any case. Legacy systems are also likely not to have good coverage or good test suites, and um, understanding what to test is a problem when you're there, right? Maybe you have millions of lines of code, a couple of hundreds of flows that you want to get tested, and if your mission is let's test it all, you're going to fail because that's too big of a mission. You got to focus. My suggestion is get together with this team and come up with a test plan. A test plan should be basically a list of things you want to get tested that are very, very important. A good definition for me of what a test plan is once you get this test plan done, you should feel comfortable in deploying that application, because if the tests are green, you're confident that the application works. Note that you don't need 100% coverage to get such a confidence, right? You can test a lot of stuff, you can leave a lot of stuff out and still be confident enough to push to production. So that's what a test plan should be. Help your people to prioritize what's important, what's not. From my experience at Agile, this is very hard. Even if you give this task to the team that is really working hard and for maybe years on that part of the legacy, they still don't have a lot of clarity on what needs to be tested. So involve developers, involve your senior engineers, your staff engineers, your product managers. Try to come up with this minimum viable test plan, and this is what you should focus on. Another suggestion, focus on business. Also another lesson learned from our initiative at Agin, that if you just give this task to the team, maybe they will approach it from a very technical point of view. For example, let's just get coverage in those 20 classes, and then a developer goes there, writes unit tests for those 20 classes, and in the end it was like, okay, cool, that's very nice, 20 classes that are tested. But if but you don't know if the software still works, right? So what you want to really get tested is business. What are the 20, 30, 40 business flows that really truly matter in production, and those are the ones you want to get exercised. Code coverage can be a great tool to help you. I know a lot of people hate code coverage. I'm here to try to debunk this myth that code coverage is bad. Sure, code coverage can be tricky by people. It's easy to cheat the metric, but if you're using the metric with the right purpose, it can help you. How? Because if you look at coverage, it will, in a legacy system, it will quickly show which areas of the system are not tested at all, and that may help you prioritize. So you can combine your test plan that has a business focus with your code perspective and see, you combine both information to decide what to test. Um, I don't want to dive into should we have quality gates that aim for coverage, so on and so forth. That's a different discussion. I'm open to discuss this in another moment. But let me just tell you that although we can track code coverage, there's a good amount of research that shows some interesting correlation between the coverage a test suite achieves and the number of bugs it can actually catch, right? Its effectiveness, how effective a test suite is, it is correlated to the coverage. That makes sense, right? A test suite that covers more is more likely to find a bug than a test suite that covers less. A test suite that has 90% coverage, supposing you wrote good tests, is much better than a test suite that covers 20%, even if this test suite was also written in a proper way, because you're just covering more. So uh, the lesson learned here is maybe 100% coverage doesn't say much. You can still have bugs, of course, but very low coverage says a lot, right? Says you don't have tests, and then you have to work on it. If you're going through a very large testing transformation, you might need some allies. You alone is just one person, and there's an army of hundreds of people that you have to convince to change their mindset. So you need allies, you need champions, evangelists that can help you pass the message that testing is important. So at Agent, at the very beginning, when we started to push for more tests, we decided to assign a test champion per team. And the test champion would be the point of contact to my team. So this would be the person we sort of held accountable for the test plan, but also the person had the internal mission to talk to their team members about, hey, we need to get better testing because we're not doing so well here, and there, right? So as soon as you have allies in the teams, it's much easier. It's much easier for psychological behavior. It's much easier for you to be convinced by someone that you work every day together and you have lunch every day together than by a stranger, between quotes, a person working for a platform team that may not truly fully understand your context. So lesson, look for champions to help you on this mission of scaling testing. Tracking progress, organization, what do you need from your organization? So if you're going through this large transformation, you surely will need the company's buy-in. It is very hard to do big initiatives in a bottom-up manner, right? The top needs to support because at the end of the day, it's all about priorities, right? And the teams are not slacking all day long. They are building stuff. They're building actually the features that pay our salaries. So they have a lot of things they need to do. And then if you say, hey, you also need to, write lots of tests now, put this in your backlog. Of course, this will have less priority if they don't have a lot of support to understand the need, and if there's no top-down message saying, folks, reliability, quality is key for us, we gotta change the way we're approaching quality. So try to get the company's buy-in. One challenging in there is that testing in general is something that only pays off at medium and long term. In short term, it's very hard to see benefits. Imagine you have like 2% coverage in a module that is super important, and the developer spends the day, and then she moves the needle from 2% to 2.5%. She wrote 10, 15 tests in a day. What difference does this make? Probably very small in comparison to the whole. It needs a lot of testing until you start a lot of tests until this starts to pay back, right? Until those tests start to break in the pre-merge and the developer's like, aha, this test really caught a bug, right? So you got to explain to people that this is not going to be something you are going to improve, change in a week. It is going to take time. It is sort of an investment you have to do, and maybe if you took too long to start this, it might cost you more. But I promise you, once you're there and you have a good test suite, life will be so much better. Tracking is very important so you can understand which teams are doing good, which teams are not doing so well, so you can enable them even more. Things you can track: coverage, completeness of the test plans. You can put some business perspective slash architectural concerns on this. Like, for example, if you have a lot of jobs and endpoints, you can measure how many of those are covered, and track these over weeks to see if people are improving. So measuring is also very important to understand if your initiatives, if your ideas are paying off, right? Um, Traceability matrix, this is something we recently introduced. That is, we let product managers to write the most important flows in a tool, and then these flows are then linked to automated tests, and then we can easily see if those tests for those flows are green or not. So it really helps you to track important business flows written by a business analyst, product manager, whatever you call in your company, to automated tests. Beyond testing, testing is just a start, right? If you're walking this reliability lane, you also need to think a lot about monitoring, right? So you need to work on observability, alerting, SLOs, right? Because testing focuses a lot on, before we get to production. But it doesn't matter how much effort you put in large complex systems, you still will have bugs. They are unavoidable, unfortunately, or at least, up to the knowledge we have today. So what you do is, okay, you assume you're going to have bugs, but you want to be sort of the first one to know you have bugs, right? So you need proper observability. You need alerting so people get notified when something happens. You need SLOs to understand how you're doing, and if you're breaching any of your contracts, for example. The possibility of doing partial rollouts is also very important. In large scale systems, maybe you don't want to push a feature to production to 100% of your user base, because if there's a bug, this affects everyone. So you want to have the ability of pushing the feature to like 1% of your user base, and then you monitor, then 2, 5, 10, whatever your thresholds are. So you slowly build trust that your code works in production until you open. And this is really important because if you start to see like this is crashing, you can, at a click of a button, disable the feature, and then the bug stops. You're still, of course, back to the old version of the feature, but it's a working version of the feature, and maybe that's better than a broken version of the feature, right? Especially for us in the payments domain, we don't want to reject payments because of a bug. You want to have a great continuous integration, continuous deployment pipeline. So from a deployment perspective, if it's easy for the team to deploy, that's great because you approach problems in a different way. There's a problem in production, you get information because your observability is great. You patch, you deploy, in a couple of minutes, the patch is in production and this bug is not there anymore. So automate your deployment as much as you can. From a CI perspective, you want to give good signals to people that their code is working, right? So you want to make sure that you can run all their tests, that you can run all their post-merge tests, that you give them decent information if a test breaks. Maybe you want to have static analysis to complement for things that people are not so good at testing. And whatever other checks you feel like you can automate to help people understand if they wrote something broken or not. Yeah. Cool. So that was my talk. I spoke a lot and very fast because I wanted to cover so many different topics. So we spoke about how to scale testing from a perspective of making sure the organization, all developers are writing lots and lots of tests every day. We spoke about testing legacy and how some existing advice is not so good. So focus on finding a way to test the code as is, come up with a test plan, track. Organization wise, we said that you need uh, top down support so you can do the real transformation. And testing is only the first step of your journey. Your journey for towards reliability doesn't should not stop there. I hope you uh, enjoyed my talk. I hope you learned something. I'm always open for comments and feedback. Drop me a message on Twitter or on my email. That's my website. See you soon.